Jumanji cooked this one.
I'm on a roll, you on a roll. Nicknamed you Aaliyah, you rock the boat. Everything that still hits you, you still afloat. Don't make no plans on me, go with the flow. Hey, hey, why you laugh when I'm being serious? It's not a joke. Say you want me to leave, you don't want me to go. Ask you if you sure, baby girl, I got more. Thought you was digging me, like my name was Soil. Hey, hey, hey. Bet that I don't love you, time to pay up, girl, it's payday. Found my moral compass, now I'm back, but then you went astray. Got another nigga, he don't love you like that anyway. Girl, you got a thing of hypnotizing with that ass and face. Cuffing pretty bitches, yeah, I know that that's the fashion. These the misadventures when you're fucking with a bad bitch.
This bad bitch, head on the swivel, all in traffic. Watching every nigga that walk past me. Cuffing pretty bitches, yeah, I know that that's the fashion. These the misadventures when you're fucking with a bad bitch. Bad bitch, head on the swivel, all in traffic. Watching every nigga that walk past me. It's clear to see, I'm not a solid. Why you playing with me? Why you playing with me? Thought you was fucking with me. I caught you slipping, it took me to see how could this shit really be, Fuck a double standard, man, I set the standards. She get wild and shake that ass when she start seeing cameras. It get hotter than tamales when she throwing tantrums. But that's my baby, my little baby, so
you on a roll, nicknamed you Aaliyah.
Bobby Banger.
Everything that still hits you, you still afloat. Don't make no plans on me, go with the flow. Hey,
How's the audio? How's the audio?
We good, and we live too. We good, you sound good.
All right.
We in the game.
Watching every nigga that walk past it, yeah. Cuffing pretty bitches, yeah, I know that that's the fashion. These the misadventures when you're fucking with a bad bitch. Bad bitch, head on the swivel on the traffic. Watching every nigga
Loud and clear,
that
bro.
walk past it, yeah.
What's going on, Anthony? Peace.
Peace to you. And who else on here?
We ain't started yet. You moving quick. Yeah. Boy, let's let the people get up in the building, man. Let's get them up in the building. What's good? I see question marks. I'm trying to figure out what's all the question marks for. What's the question marks for? Let's let the people get up in the building, man. Man, hit a one if you can hear me. Somebody hit that one. Y'all know y'all can hear me. Y'all don't count.
Right.
Y'all ain't counting. Y'all not counting. Let's see. I see we live. All right. Some people get in the building, man. Yeah, it's early. Get it in and get it
I
out.
like that three-piece. I like that three-piece you got sitting right there next to you, man. Those 3 books.
Oh man, look, yeah, come on, man. This is what we reading to understand this cosmology right here, man. You know, that's what we doing. All right. We definitely doing that. Yeah, I know we're gonna have a powerful show, man. I don't know why the numbers ain't registered. Where y'all at, man? Early.
I think the brother Sinetta, he's live. He's doing a replay of some conversations between Jabari and brother Reggie. So he's got about 500.
All right,
like we say 5,000. So he's got about 500,000 over there. So yeah.
Yeah, we in here, man. We're gonna be doing some teaching today. You know what it is, man. Pseudo Kill Official, the pseudo robot goddess. Pseudo robot.
About to spill the beans.
The pseudo robot. Nah, man. Yeah, we here. All right, let's let the people get in the building a little bit, so we can go ahead and push the line we supposed to always push, man. We done had some real interesting conversations. Some very, very interesting conversations going on in the community. And no, we ain't forgot about Pseudo Sanchez on his head all day, every day, man. This show right here is going to help dispel some of the misinformation that people are actually putting out when they deal with just the whole cosmology, the origin of the universe, what they think the origin of the universe is, what's not the origin of the universe. Yeah, we're gonna get all that. We're gonna get all that settled. Break it down and find pseudo killer fashions, man. Appreciate Sarnetta University having us on tonight. Appreciate that. That's love right there, man. Always need that support to teach ideas coming straight from science. There's a mix-up in our community, and we just want to make sure that we have the stuff, just have the quality, the quality of what we actually talked about. Yeah, and we need that, and that's a good thing to have. People that's dedicated to making sure we exactly where we need to be at, man. So how y'all fellas doing, man? We ain't start yet. Just, what's good with y'all, man? How y'all doing, man? Y'all all right?
Oh yeah, absolutely. And I think it's only right that we bring some hard science over to Sinetta University, right? So they're doing this in conjunction with the Pseudo Killas and the Real Black Atheists as well, right? Again, we've had some conversations within the community talking about, hey, we really need to start using models to describe and have descriptions and sort of frame these conversations that we're having regarding science in the community. And I think this is one of the opportunities that we're going to take to use some real hard scientific models to really frame our conversations. So, yeah.
Yeah, I know. Where you at, Kent? You disappeared. Ain't no disappearing. Nope. Not
I'm
today.
right here. I had to go
No,
run
you
through
ain't.
quick. What's going
I ain't
on?
heard you. Can't hear you, Mike. Can't hear you. Can't hear you, Mike. Check. You might gotta hook it up to the thing. Make sure your settings. Put your settings and plug your thing into it.
All right.
On lock, yeah. What's going on, Anthony? How you doing, brother?
Oh, I'm chilling, huh? Chilling. Peace to everybody on the panel, everybody in the chat, if anybody in there. But yeah, we
Yeah,
chilling,
man.
man. I'm
I
I'm
see
getting ready to
you out
fact
in
check.
your observatory. I see
Yo,
you're
NASA
out in
tonight, huh? I'm gonna be fact
Okay.
checking NASA.
Okay. All
Yeah.
right.
hear me?
I like that.
See, over here, we don't just dog them out. We gonna fact check. 'Em, You know,
Yeah.
we got the
Yeah.
tools to to fact check NASA.
Y'all still can't?
You
that
did?
Celestron there, right?
What you say, Kent?
Yes, sir. Yeah.
I said y'all still can't hear me?
Yeah, we
I
can hear you.
Oh, okay. I was just making sure.
Yeah, we can hear you, bro.
Working. What's going on with you though, man?
Hey, we just chilling. Right here. We got my main man, politically incorrect. What's up, Vance? What's good with you, man?
I can't
Can't
call
hear
them.
you. Can't hear you. Go ahead.
You can't hear me?
I can hear you now.
You can hear me?
I can hear you. What's good,
I
bro?
said, what's going on, everybody? What's going on with y'all? What was I about to say? Oh, yeah, just making my occasional appearance, being that I'm on the graveyard shift. I can't get in here too many times. And y'all going a little bit earlier today, so I'm trying to be on the panel while I can.
Yeah, we want to make sure.
This is my last week at this job, though. So this it.
Okay,
I'll be able to tap
stepping
in with
out
y'all a
there,
lot more
right?
frequently.
Okay.
Yeah, yep.
Tapped in. So my man, yo, we I appreciate all the conversations, man, that come from your mind, man. I appreciate all the brothers. Yeah, we always having these great conversations, and I think it's just, let y'all in on, just some of the conversations. And what I will say is, that people teach the flat earth and it makes sense. Okay? Like when you go outside, man, look, the earth flat, man. There's no way to judge the scale and the size of the earth. You can't even imagine that. What would you put it up against on earth? What object on the earth is bigger than the earth that you could actually see and make sense of? How big is the ocean? How deep is the ocean? Have they explored all the earth's oceans? Have they figured out everything on earth? No, they have not. But you would think they have. That's common sense. Yeah, we know everything is and no. We got it. No, that's not it. So to think that people would actually be able to walk outside and understand geodesy, which is the size and shape and orientation of the earth, is ridiculous. And so we always up against it and we always behind. We can't actually compete with that. Your mind, the brain, your Stone Age brain is actually designed to listen to something like that because you can look outside your senses. Your senses tell you that the earth is flat. Your senses tell you that we don't have a common ancestor. We not family with the monkeys and the chimpanzees. We go to the zoo, they smell a certain way. We don't smell like that. And when something smells like that, we get away from it. So all a person got to say is, no, we have nothing to do with monkeys and chimpanzees. It's common sense, right? It makes your senses, your eyes, your ears, your nose, all that tell you that monkeys, chimpanzees, and a roach has actually nothing to do with us. How do we defeat that? How do we get that? Well, why are we breathing? What is it that we breathing? We can't see it. We can't smell it yet when the wind blows. Maybe something toxic in the air, you can kind of smell it, something smell bad, but what are you talking about? So a person, right, the pseudos take advantage of all these things I just said, and they plug in their complete foolery, and all of us are susceptible to it. Our very senses that make us human make us susceptible to these bad ideas that these people have been promoting. The conscious community has been very illiterate for a very long time. I'm gonna say this again, the conscious community has been very illiterate of matters of science for a very long time. The literacy level just wasn't there for science. And how do we know? Because there's information in full detail that explain the things that we're talking about, and it's been there way before we even came around. Thank goodness. When I came into the environment, there was no sources allowed. It was who could talk the best. Who could give you that common sense science? If a person says it's common sense science, he's trying to fool you. So then let's go ahead and get this thing straight, man. Let's get it started, man. Look, Black African power, y'all, was good. What's happening? A well-organized lie defeats a disorganized truth every time. Woo-hoo-wee, man. Y'all already know what it is, man. It's the pseudo killers on deck. And we come to do what we got to do, and we're going to do what we got to do. We standing tall, we standing strong, pseudo killers on deck. Yeah, and we right here in Sarnetta's University, and we all sourced up. Anthony Bowman, what's good, brother? The man with the telescope, space age African. Right? What's good with you, man? Space Age African Astronomy Club, man. Got that powerful catalog. What's good, brother? What it do? What it do? What it do?
I'm with you, mom. You come.
I can't hear you. Mute out. I got you. I'll come back to you. Serious B. That's funny as hell right there.
Hey,
Serious B in the building.
Remnant from the some of the Dogon tangles that we had, right?
The Dogon.
So, yeah, exactly.
They did say they didn't say it. They did say they didn't say it. They did say it.
They didn't say they saw it. They saw it. They
knew about it, but they didn't know about it. They didn't say they knew about it. Somebody said they knew about it.
hey man, shout out to Sean, man. Make sure y'all like and subscribe to the Sign with Sean, man.
Peace to brother Sean.
Yeah, what's up though, Serious B? I fucks with that name, excuse my language, all day.
Right. Again, right, we come tonight to do what they say that we couldn't do, right? Which to describe the natural world based on our scientific models, right? When we say our scientific models, the scientific models that are used based on the consensus, the existing consensus of science, right? That's what we come to do tonight, right? That's what they said that we couldn't do, right? So now it's, okay, stay right there, right? So that's what we come to do tonight. Absolutely.
Mm-hmm. Brother Kent, Claude Kent in the building. What it do? Don't hurt nobody, man.
Man,
I know they scamming around you. Nah, man, get it in. What's going on, Claude Kent? What it do?
Ain't nothing, man. First off, man, I appreciate the the gear. You know what I mean? Appreciate.
Yeah. Oh, let me see what you looking like.
Right,
yeah, it's kind of fresh.
Make
yeah,
sure
it's kind of fresh.
Yeah,
it's fresh.
Have Joanne, y'all get that. You know what I mean? You got all kind of colors. And I owe your boy an apology, man. I thought he knew what he was doing. I thought he was scamming, but when we talked earlier, man, you made me think about it, and I think he just really just don't. I don't know that you said that archaic brain.
Yeah, that archaic brain, yo.
I might have to have a little more compassion for the brother, man. Just hopefully he'll hear something that help him get through it. But
I saw that you did a brief showing over at his channel.
I was
right?
like,
again, we all know that Kent isn't necessarily the most diplomatic one of the pseudo killers, right? He's like when the Marines show up at your door, right? They're not there to negotiate. They there to kick down the door, right?
Nah, I'm like, man, stop the BS, man. The jig is up, man. What you doing over here, man?
Gig it up.
You know what I mean?
right.
But hey, some people really believe the stuff he talks, and he might very well believe that. So I mean, but he gonna still get beat up though. We still gonna beat him up, but
Oh yeah, he ain't done yet. We've been beating him up for a couple days, man. Hey, Vance, what's good, man? What it do, man? What it do?
Pseudo Killers on deck. Just trying to get my little time in while I can, man.
I know you got about 5 minutes left, man. I already know.
Nah, I got about 30.
Oh man, you got about 30. We gotta crush you in like right now, man. So question, man. Your age group, young brothers, man, 25-year-olds to the 30-somethings, man. What's your general conversation around these things, man? What's the level of literacy in science? What you thinking based off your conversation with your brothers, man?
Man, most everybody whacked out, pseudoed up. They need the crystals, they need the frequencies, they need the alternative blackology history. It's only a handful of guys I can have a real conversation with. The rest of them, they looking for the spectacular information. So it's crazy. It's ugly out here. Any of the guys, I wrap it up. They reference me to Hidden Colors, Umar Johnson, Billy Carson. I'm like, crystals is crazy. It's crazy. They whacked out, yo.
And who do we have to thanks for that? Just the conscious community, because the conscious community is now mainstream. Y'all missing it.
Exactly.
I came in battling, the old school conscious community, which was the first joint. And now there's a new school, bro. And they getting 1 million views and they on the Breakfast Club and it's just translated over. So Vance, I remember us having one of my favorite conversations about us going interstellar, man. What's the name of them 2 probes, man? I always forget them. I don't know why.
Oh yeah, the Voyager probes. Yeah, launched in the early 70s.
Why they special though? What was the reason for
them? They were supposed to make contact with alien life potentially, or send signals to any life that was out there. That's really what they were supposed to do. And on the way out the solar system, they were supposed to take some snapshots of the different planets and suns as they got the gravity boost from the different planets. So yeah, it was early primitive technology compared to what we got now.
Did you say gravity boost? How so? How so is gravity existing in the the Sanchez universe?
Yeah. So they'll I forget the official name, but what they'll do is they'll make a couple orbits around the planet, and it'll speed them up essentially. It'll give them a lot more momentum than they previously had, and they'll do that each time they go around the planet. And they particularly do it around Jupiter, being it has the most gravity amongst the planets, and it'll kind of slingshot them further out into the solar system. And there was New Horizon was one of the more recent probes that did it, which was going to Pluto. It went around Jupiter a couple of times and it slingshot out of there. Gave us our first pictures of the Kuiper Belt and some the real pictures of Pluto, not just the little dot that we've previously come to know. But yeah, that's all it is.
See, man, yo, you always told you, man, you give me hope in moving forward, man.
Oh
really, yeah, you give me hope in moving forward, man. So, all right, let's jump in, right? I want to read something and let's get it right into. We're gonna have Brother Kent. He gonna start us off with a I'm not sure which who going for Anthony, Kent, Brendan.
There's mostly Anthony and Brendan kind of put this together. I know Brendan did the slides or whatever. So
you're not ducking out, Kent. No, Kent. No, sir.
I'll start it out.
No, sir. No, serious B. No, sir. Brother Kent, we'll be doing a presentation today starring Brother Kent. Let me read this and get right into it, man. That's funny as I don't know what.
Hey. Go ahead, though.
All right. So we do this. Where did all this come from? In every direction we cared to observe, we find stars, galaxies, clouds of gas and dust, tenuous plasma, and radiation spinning the gamut of wavelengths, from radio to infrared to invisible light, gamma rays. No matter where or how we look at the universe, it's full of matter and energy. Everywhere and at all times. And yet, it's only natural to assume that it all came from somewhere. If you want to know the answer to the biggest question of all, the question of our cosmic origins, you have to pose that question to the universe itself and listen to what it tells you. This is where science jumps in. And this is one of my favorite sayings right here, right? And if y'all can get this book right here, Neil deGrasse Tyson, Astrophysics for People in a Hurry, because all of y'all in a hurry, right? You should get this. But right here, this is my favorite thing right here, right? This statement right here, man, this is fire right here, all right? It says, the universe is under no obligation to make sense to you. That's Neil deGrasse Tyson, man. Simple as that.
That's powerful.
Simple as that. And so don't let them flim-flam you. Don't let them make it up. We have a powerful tool that humans have put together, and it's called science. And science answers the question of understanding natural phenomenon way better than religion. Religion answers the question of the supernatural. Ladies and gentlemen, whether you believe it or not, we live in a natural world. So who going first, man? Let's get into this Big Bang and what it is, what it's not. You know, is it the origin? You know what I'm saying? Lithium, what nuclear synthesis, redshift, Hubble expansion. You know what I'm saying? Let's get it in, man.
Right, I'm gonna go ahead and share my screen. And let me know if you can see this.
Bob, I see it. You right there.
All right. So of course, right, the topic of this conversation is going to be the evolution of the universe, right? So if you see at the very top left, we have an image of the sky map, the cosmic microwave background, right? In the very middle there, you see that cone that represents a visual representation of the cosmological model of the Big Bang, and towards the very right, you see that we have the four fundamental forces there, right? And before we get into it, of course, we always got to do our disclaimer, right? We've got a couple videos teed up, right? This is going to be for entertainment purposes, teaching purposes. Again, we're covered under the Copyright Act of 1976, right? So we always like to put our references up front in front of the people, right? And these two particular references, these are outstanding collegiate level textbooks regarding both astronomy and physics, right? So to the left, you see the Essential Cosmic Perspective. This is one of the texts that I actually used in college. This is during undergrad when I had an astronomy course, right? This is the 2018 version of the Cosmic Perspective, right? Again, you can get this off of Amazon. The digital edition is published by Pearson, right? The other one, this is Physics, the 12th edition by Cutnell and Johnson, right? It's outstanding, right? It covers everything from kinematics. It covers thermodynamics. It covers general relativity, special relativity. If you're not shy on getting into a little bit of mathematics, go ahead and grab this particular book as well. This was published in 2021, so this is very recent here, and both of them are outstanding references there. I think both of them have a digital edition as well. So let's go ahead and frame and talk about the purpose of this particular discussion, right? So again, this is going to be a cosmological deep dive discussion we're going to have, right? So we're going to review the Big Bang Theory and its associated model, right, which explains the origin of the entire universe, right? So we're going to be applying the currently known and tested laws of physics, right, that kind of explain how the universe began as an incredibly hot and dense collection of matter and radiation, right? And through that expansion and cooling over time, right, this whole mixture of particles and photons actually resulted in the universe of galaxies and stars that we see today, right? So we're going to go through the 8 evolutionary epochs, right? These describe the unique sets of conditions that were present during the universe's 13.7 billion year life cycle, right? That's that currently known, right, age of the universe, 13.7 billion, right? And also we're going to frame the conversation using time, temperature, and descriptions of the conditions during the 8 evolutionary epochs, right? So we'll review all the empirical evidence that supports the Big Bang model. And where applicable, we're also going to talk about the limitations and some of the things that we don't know, right, based on the model as well, right? So before we actually delve into a cosmological discussion, right, we wouldn't be doing ourselves justice without actually reviewing, right, just a brief little review of the 4 fundamental forces that we see at work in the physical world, right? So everybody knows these. You probably taken this, talked about this in grade school, in high school, in college, but let's go ahead and do just a brief primer on those 4 forces, right? So of course we got gravity. This is the big question, right, in terms of the gravity with the flat earthers, right? So what gravity tells us is that all massive objects in the universe exert this attractive force on other massive objects, right? And according to Newton's universal law of gravitation, right, we say that the magnitude of that gravitational force depends on the mass and the distance between the objects at play, right? So consider gravity as that great creator and destroyer of worlds, right? It's that force that drives nuclear fusion in the center of stars, right? And all of the creation and the motion of the galaxies throughout the cosmos, this is governed by the force of gravity, right? And in terms of Einstein's theory of general relativity, he describes gravity as a force that actually affects the geometry of space-time. We won't go into relativistic phenomenon today, right? But in terms of relativism, you think about things like time dilation, right? The fact that clocks tick slower, right, when they're in close proximity to massive objects, or gravitational lensing, the idea that massive objects can, like suns and black holes, can actually bend and warp space-time, right? Those phenomena are all included in Einstein's theory of general relativity, right? So the next one is the strong nuclear force, right? So think about the strong force is that attractive force at play within the center of the nucleus of an atom, right? So the strong nuclear force, it operates at very limited range, right? So think about inside of a nucleus, right? It's that attractive force that you'll see that holds protons and neutrons together, right? And this is the force that actually allows for the existence of stable atoms inside of our universe, right? So the third one, the electromagnetic force, right? That's, one of those, topics that I've always brought up during the flat earth as well, right? Electromagnetic force being that it's the force that deals with electric charge of massive particles, right? Think about the electromagnetic force. It pulls negatively charged electrons within a bounded orbit around those positively charged protons in the center of the nucleus of an atom, right? So this particular force, this allows for the creation of stable molecules inside of our universe, right? And the larger the nucleus of an atom, the more electrons are going to be pulled within that bounded orbit around the nucleus. So, and ultimately what that does, that balances out the electric charge of the atom overall, right? And also photons, right? Light itself, right? This is also, affected by electromagnetism because, as light propagates throughout the universe at various wavelengths, right? It's actually, you're generating electromagnetic fields, right? So the last but not least, this is the weak force, right? This is considered weak in comparison to the strong force, right? So this force allows for the creation of things like complex nuclei, right? And it plays a critical role in things like fusion, fission, like these nuclear reactions. And it's called the weak force also because it affects weakly interacting particles such as neutrons, right? So think about things like radioactive decay, right? The weak force is actually at play during radioactive decay. And one thing interesting about the weak force as well, this is the only force that actually behaves differently based on the spin state of the particle. All right. So you guys got anything, any questions or any statements about the 4 fundamental forces?
Those 4, man, I think everybody need to learn that, because I see people running around, they try to just start eliminating forces.
Right.
Yeah, it's basic, man. So yeah, so people talk about we don't want the basic, we want the high level, man. This is the high level basic right here. If you don't get the fundamental forces, the 4 fundamental forces, then how you gonna make sense of anything? This is how nature's actually talking to you, and science has identified it. Remember,
Right.
that's all science is, to know. Go ahead, bro.
We can't even really have a meaningful conversation regarding the cosmos unless we're rooted in those 4 fundamental forces, right? Because a lot of the conversation is going to be centered around the behaviors of that, right? And we'll get into that.
All right, once they eliminate gravity, yo, it's a wrap.
Oh yeah, one of the ironic things is like gravity being one of the first forces that actually emerged after the Big Bang, and its importance, and its ultimate, basically, the overtaker of all of the forces ultimately, right? As the cosmos continues to age, right? There's a lot of postulation that says that gravity may be the last man standing at the end of the day, right? Because it just is that it's unrelenting, right? It's an unrelenting force that ultimately will overtake the entire forces, all the forces. Absolutely.
As well as you get spheres because of gravity, because of the way they develop. You know what I'm saying? Called the planetesimals, and how the gases and stuff form when gravity brings it in.
Yeah, absolutely.
Hey, didn't we have a conversation about how nature actually forms things? We kind of talked about that.
Yeah.
They ain't just flatten out. You could look.
It's really centered around the mass of the mass of the object. And once it reaches a certain mass, it's just generally going to start to become a spheroid shape, due to gravity. Gravity is pulling everything to the center of the mass. You know what I'm saying? So that's how water and everything we know can stay on a revolving sphere, because on the molecular level or atomic level of everything, all matter is being pulled to one central point. So that's how we can, stay on a revolving sphere.
Right, and that's a good point. When you're talking about at cosmic scales, Anthony, right? Gravity becomes that overarching force that's at play. When you're dealing with galaxies and planets. At the quantum level, right? At the atomic level, you're going to have interactions with the strong force and with the weak force and the electromagnetic force, right? When you're talking about bonding molecules together, right? That's when you're talking about the electromagnetic. When you're talking about having a stable nucleus, that's the strong. But those forces are pretty much overtaken on astronomical scales, right? So, like for instance, what moves a galaxy around, right? You're not going to see those other forces at play. What you're seeing really is gravity at play there, right? So, absolutely. All right, so this particular image, this is a very interesting image, right? This is an image of the standard cosmological model, right? And what we're seeing here, this is based on what we call the Lambda CDM model, right, of the Big Bang. Of course, I think a lot of people may not understand or acquainted with, there were several different versions of the Big Bang theory. And the current most acceptable model amongst the consensus of scientists is the Lambda CDM model, right? CDM meaning cold dark matter, right? This particular model, it accounts for dark matter in the universe. It accounts for dark energy, and as well as all normal matter inside of the universe. So what you see here it shows a chronological timeline that's showing the time, the temperature, and the state of those fundamental forces during each of those 8 evolutionary epochs throughout the evolution of the universe.
Gotta move that comment out the way. I was trying to see that bottom.
All right, so I'm not gonna watch this right now. I'm gonna come back to this video. Let's see here, skip on. All right, so one of the questions that we always get, right? You say, well, no one was present during the early evolution of the universe. So how do we know about the conditions? How can scientists say with a high degree of certitude what was happening back then, right? And fortunately, a lot of the pressures and the conditions that existed during the early universe, those are very similar to the conditions that we observe within the center of our stars, right? So based on that, we can actually use the same laws of physics to determine what the early universe may have been like, right? So think about this, similar to like if you compress a balloon or you take a piston in a car, you press that down. But what we're doing this at extremely high temperatures, extremely high densities, right? So knowing that the universe is pretty much expanding, right? This is based on Hubble's discovery. You know, we have the rep shifting of the light. We won't get into that. That's a different conversation. What scientists essentially do, we use those laws of physics and we turn back the clock, right? And then we measure the temperatures and measure the conditions, and then we have descriptions of what the universe may have been like during those evolutionary epochs. Right. So let's get into the very first evolutionary era, right? This is called the Planck era. So again, this is named after the famous German physicist Max Planck. He's a theoretical physicist. He actually won the Nobel Prize for his theory of quantum theory, right? So I think he's a really brilliant guy, right? He pretty much single-handedly invented the field of quantum mechanics, right? So the quantum or the Planck era actually happened when the universe was about 10 to the minus 43 seconds old, right? And 10 to the minus 43 seconds, that's an interesting time period, right? Because that's what we call Planck time, right? In science, Planck time is the smallest unit of time that we can currently measure with our tools in mathematics. And according to the laws of quantum mechanics, right, the universe was undergoing enormous energy fluctuations and tidal forces during the Planck era, right? So this would be a time when both mass and energy were pretty much equivalent. And the temperature of the universe during the Planck era was about 10 to the 32 degrees Kelvin, right? So in terms of the magnitude of that number, right? Imagine a 1 followed by 32 zeros, right? So we're talking trillions and trillions and trillions of degrees hot, right, within the universe, right? So these massive shifts of the gravitational fields, right? Scientists actually postulate that all of this caused a warping in space-time. And also the 4 fundamental forces that we just talked about, right? These all were unified in what we call a single unified super force during the Planck era. So in what scientists call this, they say that this must have been an era of ultimate simplicity, so to speak, because all the phenomenon that governed the natural world at the Planck era, all of this was governed by a single unitary force, right? But one of the problems with the Planck era, so we talked about, we have to be honest with our limitations, is that our understanding of the Planck era is highly speculative right now. And the reason why is because we don't yet have a theory that unifies both general relativity and quantum mechanics, right? You know, general relativity being the theory of the very large, like we talked about, you know, on astronomical scales with galaxies and all that, and quantum mechanics being the theory of the very small, right? That's at the subatomic level, right? So until we can come up with that theory of everything, right, that unites both quantum mechanics and general relativity, we may not be able to say with a pretty high degree of certitude what the conditions of the universe were during the Planck era. Right. But that said, we do have an idea of what may have happened immediately after the Planck era. right? So eventually the temperature within the Planck era dropped down low enough for gravity to freeze out and operate as a distinctive force on its own, right? And the emergence of gravity, right, during the Planck era, that pretty much marked a phase transition into that next evolutionary era that we call the grand unified theory era, or the gut era. All right.
Hey, Brandon,
So,
can I say something real quick on that?
absolutely.
On the Planck era, where you were saying that we just don't know what's happening there. That's
Right.
not a knock on science. You know what I'm saying? The way I see it, that's an opportunity for whoever's listening to this to get their child involved in STEM, and they may be the ones who can figure this out. You know what I'm saying? Instead of sitting back, just listening to some dude tell you, well, the Most High told me. You know what I'm saying? Get your kids involved, and they can be the ones that figure this stuff out. That's it.
Oh, absolutely. And one of the interesting things when we talk about the Planck era, people say, okay, well, what may have happened, or how could the universe existed, or what were the conditions before the Planck era? And actually, it may not make sense to say what happened before the Planck era, because our very understanding of time, right, we don't even understand how time existed during the Planck era. We don't know how space, right, actually existed. And one of the problems with is, like, anytime you try to make a calculation, right, measuring or doing anything beyond 10 to the minus 43, right, you get things like infinities and black holes will pop up in the physicist's calculations. That's how we understand, or that's how we know that we're missing something within our equations and our current understanding of science, right? Because we get unnatural, we say phenomenon or unnatural results that we don't see. So, but again, yeah, this is an era that's ripe for research and for people that are really brilliant, for really brilliant scientists. Absolutely. All right. So the grand unified era, right? So again, the gut era gets its name from the grand unified theories. And keep in mind, there's more than one grand unified theory, right? But what's consistent among the grand unified theories is that they predict that the strong, the weak, and the electromagnetic force were unified during this time, right? So you had two forces at play within the universe, right? And keep in mind, this is still at temperatures above 10 to the 29 degrees Kelvin, right? So in terms of this, right, our understanding here is also very limited, right? But also similar to the Planck era, right? Scientists say at the very end of the gut era, which was very, 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 very short, right? We're talking about trillions of a second short after the Big Bang, right? What happened was the freezing out of the strong force, right? That strong force that we talked about as a unique force inside of the universe. And that happened a trillionths of a second after the Big Bang, right? So that's 10 to the minus 35 seconds, right? And again, it's like, in one of the interesting things with the freezing out of the strong force, right? What the scientists say, that this particular phenomenon triggered a very dramatic expansion of the universe that we call inflation, right? So now I do have a video that I'm going to go ahead and tee up that does a really good explanation and a description of cosmic inflation. Let's see if we can get that video playing. Let me know if you guys can hear this.
Nah, not right now. We can't.
Nope, I can't hear you.
You can't hear it? No? Okay.
See if the volume. Oh
Yeah,
yeah.
let's see if I can crank this volume up.
It's a theory called inflation. The theory is as follows. Before the universe...
Can you hear that?
Yeah, it's kind of low, but we can hear it. Not
Okay.
sure how the audience can. I don't know how they can hear it.
Yeah,
Okay.
check your settings on the StreamYard.
Okay, hold on just
Did
a
you
second.
did you click the? Now I know what you didn't do. When you
Mm-hmm.
screen share, I don't think you unscreen share it and do it again. Then click the value. It's gonna be a thing that says for audio.
Okay, let's see.
You gotta check that box.
That's what I had. I used
All
to
right.
do that on Zoom.
Okay,
Be playing the
share my
video.
screen.
Mm.
Share screen,
Right.
and I'm gonna share the window instead. And let's do that.
But it should be a box that said volume. You see it? I mean not volume, but vocals.
Okay, hold
You
on
see
just a
it?
second. Hold on just a second. Cancel that. This is present. Share screen. Share. Okay, entire screen. Share audio. Share
Yep.
system audio.
Yeah, there you go. That's what you
Okay,
didn't do.
okay. And then let me know if you can hear this.
Got hot and
Yeah, you
dense,
good.
still there, and it was
You can hear that?
Yeah, that's it. Once you click that audio, yeah, you good.
Okay.
We
I'm
good.
gonna go back a little bit here
Mm-hmm.
because this is a really good clip here. All right.
did they come from? And this is where we start to probe theories back towards the Big Bang, and in a sense, theories of what may have happened before what we now call the hot Big Bang. So if we define the Big Bang as a time when the universe was very hot and dense, we have a theory that tells us how, or predicts how, these small areas of different density could have formed. It's a theory called inflation. The theory is as follows. Before the universe got hot and dense, it was still there and it was doing something else. It was stretching very fast. It was doubling in size on very short time scales, actually around 10 to the minus 37 seconds, which as you write it out on a piece of paper, looks like this. That's why the theory is called inflation, by the way, because the thing is inflating very fast. The idea is that inflation is driven by the stuff that you put in the universe. This is central to Einstein's theory of general relativity. In this case, the stuff is something called an inflaton field. It's the kind of stuff that makes the universe stretch very fast. But what was developed was the idea that that smooth sort of ocean, if you like, field filling space, is not entirely smooth. It can't be. It must have ripples in it. It's not really a still ocean of energy. It's like a stormy sea. And what that does for you when you calculate that is it tells you as that inflation draws to a close, as it must. The universe has to stop expanding at this rate and goes through the hot Big Bang. Then some pieces of space will be stretched a little bit more than others because of the ripples in the energy field that's driving the inflation. Some bits of the universe stop inflating a little bit earlier than others. That leads, when you dump the energy into space and heat it up and make particles, it leads to a slightly non-uniform distribution of particles in the space, which you can calculate from the theory. And when you do that, you find the pattern looks like this, our observation of the universe 380,000 years later. So that's the reason why inflation is, I would say, is the most commonly accepted theory of how the universe came to look like that, which subsequently tells us how the universe looks like it does today.
All right. And one of the things that's interesting about the inflation piece, right? All of the energy that was dumped into the universe, right? This is after the freezing out of the strong force, right? And then the universe undergoes this cosmic inflation, right? And the remnant of that inflationary period, that's what we observe as the CMB, as the cosmic microwave background, right? That's the remnant of that inflationary, that all of the energy from that inflationary force within the universe, right, during the gut era. Pretty powerful stuff, right? How you feeling about this?
I was just strolling through the comments, and let me see. I want to highlight something. So, here you go. Boring church. Yeah, we get it. Yeah, we was talking about crystals and how you make the crystals vibrate and how you walk up to McDonald's and tap the sign 3 times, it can end up in a McDonald's commercial through quantum buffoonery. Yo, you be jumping up and down your seat. You be getting chills. You be really think you getting informed. And I get it. I get the whole situation. When we having conversations at the high level, when we actually trying to learn something, right? Being drunk, being high, all these things don't mix well when we actually trying to put forth the cosmic models. It just makes no sense to be that way. And so we always try to find a healthy mix of, when to bang, when not to bang, and how to do it. So this is my moment to bang. You're a straight nut. Straight nut, and the reason you're a nut is because you've never went to school. We understand you're operating at a 6th grade level. Matter of fact, underneath of that. Because anybody with just a little bit of sense understands that, wait a minute, they saying something that's really matching up that we can actually look at. We can actually pass it on to our kids. Why is it important to pass it on to our kids? Because kids, okay, that are passed down ignorance, okay, end up being the kids that you find in the juvenile system that are basically illiterate. So illiterate people produce illiterate kids.
Right.
And illiterate kids are in the juvenile system at an 80% rate. This is the crime, ladies and gentlemen, right? The people just run around gang banging. Basically, a lot of them are illiterate. A few of them are not. And they the ones that run the thing and get the things going, right? But for the most part, you're talking about a high level of ignorance. I'm telling you, I've been locked up before. You got to damn near kill somebody over a cookie. Oh, you say, yeah, what are you talking about? I am telling you that in jail, right, a bag of chips, I had stores in jail, right? This how it works. You hand out a person, say they want some cookies, you give them a pack of cookies, okay? When they go to commissary, they got to give you 3 packs back. If they don't have it on the date and time they said they was gonna have it, you gotta stomp them out. Or they gotta pay extra. That's ignorant to me. Some cookies? Right, so we not in church. Notice it's not boring. It's only boring to the ignorant because you don't even know what we saying. Back to our scheduled programming. Mr. Brendan, Pseudo Killas on deck, Bobby banging this bitch. Let's go.
All right, let's share the screen again. Again, this stuff you're gonna have to use some of your executive faculties here, right? It's not going to be easy to sort of digest, especially if this is the first time you may have heard some of this stuff, right? Again, some of the people in our Pseudo Killas discords, we have these conversations, we have cosmological conversations all the time. So I'm not really showing them anything new, but I think this is something if the people that are interested in, if they just do a little bit of research, right, we can open up and have a lot better conversations regarding the cosmos, right? So let's go ahead and share the screen again here.
Even though we've seen it before, it's still good to look at it over and over again.
No, man, come on, Brendan. I'm getting a better understanding. So if I can get a better understanding of what's going on, people new to it, people who's been around it, you just get a better, the point is we preparing you for this crazy when the pseudos come at you and start making forces disappear. But yet we'll talk about, watch this, people will make forces disappear, but yet we'll talk about the things that require the force that they just made disappear. Ain't that funny?
And that's the exciting one.
Yeah, exactly.
Brendan, what was it?
Right. Right.
What force did the man make disappear, but yet he wanted to use it to prove his flat out point? What was that?
Right. We're not going to say his name, but this was a conversation with a flat earther, right? And one of the big questions that we always have with, when we start to engage flat earthers in conversations is like, hey, do you believe in gravity? Do you subscribe to the force of gravity, right? And he was like, no. So so that begs the question, right? On Earth, right, what is the force that causes objects to accelerate towards the Earth, right? Because in physics, we know that nothing moves in the universe without a force, right? So if you're going to take away gravity, what is that force? And the answer was, okay, it's density, right? It was like, okay, well, sort of explain, right? In sort of his explanation, right, as he sort of trickled through it, right, he said, well, when you put an object inside of water, right? And the thing starts to sink, and it's sinking at 9 to the 8 meters per second squared. And then I told him right there, I said, stop. You mentioned 9.8 meters per second squared. That's the acceleration due to gravity. You're gonna have to give me that back. You can't not subscribe to gravity and then turn around and then use the acceleration due to gravity to describe your model. You can't do that. You become a walking contradiction. But again, right, a lot of times, I don't know, maybe if he heard somebody, describe it that way, but sometimes, people, they'll play on your ignorance. They may play on your ignorance that you didn't know that 9 to the 8 meters per second square was the acceleration due to gravity, right? So again, right, we're actually having these teaching moments to make sure that we don't make those mistakes ourselves. But anyway.
Hey, Brendan, in that same conversation, that dude brought up a law, which we all know scientific laws are universal. But you bring up a law, and then later on you have to recant, okay, that's not true. That means you just learned that wasn't a law instead of taking your time on your own before you mention that to the whole world to check it out. So you just regurgitate it. See, and when you got sources and when you fact checking and when you looking into stuff, you'll see, well, nah, I can't say that because this ain't adding up. So that's another thing y'all should pay attention to. These people bringing you all these scientific terms, but don't believe where the science coming from. That's crazy.
Right. Absolutely. All right.
Yeah, it happens all the time. Let me get up. Somebody said explain dark matter.
Well, we'll get into that. Right?
Black matter.
Yeah, we'll get into black matter.
Black matter. Black
We're
man.
gonna presume it was
black man.
dark matter, right? So yeah, let's do that. Again, all right. So now we're sort of transitioning into the electroweak era, right? This is the era following the gut era, right? And this began when there was a splitting of the gut force, right? So this marked the time when the electroweak era, right, was actually at play, right? And again, this is the inflationary period, right? So at this particular time, you had 3 distinct forces at play inside the universe, right? We have gravity, right? We talked about when it froze out. We have the strong nuclear force, which triggered the inflation. And now we also have the electroweak force, right? So in terms of time, we're sitting at around 10 to the minus 38 seconds after the Big Bang, right? And the temperature of the cosmos at that point was 10 to the 29 degrees Kelvin, right? So think about, the electromagnetic force and the weak force. Those were still operating as a single unified force under these particular conditions. And one thing that's interesting about the electroweak era, right? During this era, we had the spontaneous creation of both matter and antimatter, right? So this, everybody knows when a particle of matter comes into contact with a particle of antimatter, you get an annihilation phenomenon, right? And you get the creation of pure photon energy. So during this particular era, the electroweak era, right, you had the conditions that were so hot, so dense, and so filled with energy. You had the universe had the ability to create matter out of pure energy during this time, right? And also, again, the remnants of that energy is the cosmic microwave, right? So as the universe sort of continued to expand and cool, right, during this electroweak era, so eventually the temperature of the universe got to around 10 to the 15 degrees Kelvin, right? Around 10 to the minus 10 seconds after the Big Bang, right? And this was the time when the electromagnetic force itself froze out and it emerged as a single force as well, right? So during the electroweak era, right, the universe cooled, right, the electromagnetic force froze out, right, and began to operate, right? But still, think about this: the temperature of the universe was still 100 million times hotter than the temperature at the core of our sun, right? So it was still extremely hot in dense conditions, right? And one of the interesting things about the electroweak era, right? Previously, we talked about theoretical physics, right, during the electroweak era, right, this is the era where we have direct observational evidence, right, based on the conditions of the electroweak era. And we get that from our particle accelerators, right? So think about the LHC in CERN, the Large Hadron Collider, right? Those are the tools that we have to observe direct observational evidence regarding the conditions and what the universe may have been like during the electroweak era.
So I like to say this here real quick, Brendan. They use the hadron colliders to break down the atoms into their simplest forms. You know, that's how they found the quarks and the muons and all the different particles that makes up the proton and you know, the neutrons and stuff. So the hadron colliders are not used to create black holes. No, they're breaking down particles.
Thank you. That's another misconception, right? That sort of floats out there regarding the capabilities of the LHC. So that's a really great point. Right. So now we'll go ahead and transition into the particle era, right? And this is the moment, right, when the nuclear force, basically the nuclear weak force, so to speak, actually froze out and it became independent as well, right? And this marks the first instance in the evolution of the universe, right? This is during the particle era, where all four fundamental forces actually acted independently inside of the universe, right? So think about this. You know, once the universe cooled enough to prevent that spontaneous creation of matter and antimatter, right? The photons, those became the dominant form of energy inside of the universe, right? It's sort of think about, right, this the particles that were there. All of these were subatomic particles during this particular era. So you just mentioned the quarks. Like quarks are the building blocks of both protons and neutrons. The quarks actually existed independently during the particle era, right? Because of the high temperatures, right? They could actually exist without actually forming protons just yet, right? But by the end of the particle era, all of those free quarks actually had combined to form both the protons and the neutrons that we see inside of our cosmos today. So in terms of the material composition, what they say is that for every 1 billion anti-proton particles, right, there must have been 1,000,000,001 actual protons, right? It's because without that slight asymmetry in matter, right, we would have no matter within the existing universe, right? Because the particle annihilation between matter and antimatter pretty much would have just, you know, annihilated all the existing matter in the universe. But because we had that slight asymmetry, right, that 1 billion, that 1 in 1 billion leftover particles, right, or that anomaly, right, that consists of all of the matter that we see in the cosmos today, right? And scientists, they actually get that ratio by determining the number of both photons and protons that we see in the universe today, right? So when you think about the particle era, pretty much ended when the universe was like 1/100th of a second old, right? So think about it. We just went through, you know, all of these eras, right? And the universe itself is only 1/100th of a second old. Right. So the next era, or the epoch, is the era of nucleosynthesis, right? So this is the era when you had both protons and neutrons. Those began to actually fuse together to form the heavier nuclei, right? And so you think about the temperature and the levels during the universe during this time. They were so high that gamma ray radiation would actually break those nuclei apart, right? Just as soon as those nuclei would form, right? So you had this delicate dance of both fusion and demolition of nuclei during the era of nucleosynthesis, right? But eventually, you know, the universe began, you know, it continued to cool, it continued to expand, right? Where this fusion pretty much no longer could occur, right? And during this time, the universe was fusing enormous amounts of hydrogen into helium, right? So, and this was, you think about the temperatures where this was happening, right? This was like at temperatures that were a billion degrees Kelvin, right? So if you actually take a look at the chemical composition of the universe today, right, of the hydrogen and helium, right, it remains the same today, right, as a remnant of that nucleosynthesis. So you think about all that fusion that was happening. It was the entire universe was similar to the inside of a star. Similar to how stars actually fuse hydrogen into helium. That's what was going on across the entire cosmos during the era of nucleosynthesis, right? And that probably lasted around 20 minutes before it actually stopped, right? So if it would have lasted any longer, right, the chemical composition of the universe would have been much different than it is today, and the universe may not be able to sustain life.
Yeah, it would have been totally different. You know, we'd be probably, if we existed, we'd probably be saying the same thing about another element, you know, but this
Right,
is
exactly.
what we got.
Right, exactly. All right. So the next era, this is going to be the era of nuclei, right? And the era of nuclei, this pretty much lasted roughly, I think it's around 380,000 years, right? So, and during this time, but the universe, we talked about the hydrogen and helium, right? So the universe was about 75% hydrogen, 25% helium. You had some trace elements of deuterium and lithium as well in the universe, you know, in terms of those particular elements. Those are just different forms of helium and hydrogen. And the universe consisted of a really hot, dense plasma, right? And the hydrogen and the helium during this epoch, right? It didn't have free electrons. It didn't have electrons around the orbits of the hydrogen and the helium, right? Similar to how we have it today, right? What we had was ionized plasma, right? So you know, all of the hydrogen and the helium, right? It was basically, you know, it was free moving, right? And all of the electrons inside of the universe, right? Those were free. And the photons, all the photon light was basically bouncing and ping-ponging around, hitting those free electrons, right? So it was a condition where light couldn't freely travel through the cosmos during the era of nuclei, right? So it's very similar how light struggles to make it to the surface of the sun, because it's basically ping-ponging, those photons are ping-ponging around inside of the sun. That's very similar to the era of the nuclei, what was happening during the cosmos. And what's interesting about that, if you could transport your body to that era, right? If you would stand there and you put your hand in front of your face, you wouldn't be able to see your hand, because photons couldn't freely move through the universe. And the entire universe was clouded in a complete fog, so to speak. But eventually, right, the universe cooled down to around 3,000 degrees Kelvin, right? And at that point, that's when the hydrogen and the helium began to capture those free moving electrons, right? And this is going to mark that first instance where we had stable and electrically neutral atoms within the cosmos, right? And that's when those photons, all of the light within the natural universe, actually began to freely move through the universe, and that fog sort of lifted, so to speak, right, towards the end of the era of the nuclei. All right, so we're approaching the era of the atoms, right? It began right after the era of the nuclei. So this is at when the universe was right 380,000 years old, right? And this is when gravity began to slowly pull all of those newly formed atoms, right, and all of that plasma material into really high density regions inside of the cosmos, right? So think about those became those proto-galactic clouds, right? Those are the areas where entire galaxies would begin to emerge inside of the cosmos, right? And that era of atoms pretty much lasted about 1 billion years, right? In terms of, you know, collecting all of that proto-galactic dust, all of those atoms, right, in the proto-galactic clouds, all of the gravity was pulling things together to begin to form the galaxies, right? And then it transitioned into the era of galaxies, right? And the era of galaxies It started when the cosmos was 1 billion years old, and it lasts until today, until the present, right? What we call that is the stellar dawn, right? This is the time when we had the formation of stars. The first stars came into existence during the era of galaxies, right? And we also had the planetary formations. We had the forging of the heavier elements as well, due to the fusion, due to supernovas. And again, right, the era of the galaxies, during the beginning, the universe was around 20 degrees Kelvin. And eventually it cooled all the way down to the universe's current temperature, which is 2.7 degrees Kelvin. And the interesting thing about that, the 2.7 degrees Kelvin, that's the temperature of the cosmic microwave background. Right? So Anthony, this is your particular slide, right? The origins of the solar system elements. You want to go ahead and jump into this? This was a pretty interesting piece that you wanted to add some color to.
Yeah, this is the a version of the chemical element chart that most of us learn in elementary school, junior high, or high school, one or the other, if you went. But the thing about this chart is, okay, when you got good science, you can take your data and you will produce a graph or a chart. I hear a lot of scientists say that. And when it's really good, it's gonna be, it can cross over into different areas. Well, this chemical chart here, it just explains the origin and how do we get all those chemicals. So we're speaking on the Big Bang. And as you can see, looking at the chart and the legend at the top there, it shows you all the many ways that these elements are forged. And we start out with hydrogen, which is number one, you know, because it's the most abundant. But at the same time, it's one neutron, one proton. But it's the most abundant in the universe. And all the other elements are basically, come from the hydrogen. But as you can see, the hydrogen was only formed during the Big Bang. So there's no more hydrogen being produced. Hydrogen is the producer. And as you go down the chart, you'll see all the many different ways. And if you can refer back to our video on the stars, we talked about that, how the gravity and the heat in the core of the stars, how it fuses those hydrogen atoms to make helium and other atoms through different processes. So I thought this chart would be very good for this conversation because it's kind of, you can throw it in with the star presentation that we did. So just knowing how all of these elements are produced, then you can get a good idea of what was happening during that age of nucleosynthesis during the Big Bang. So y'all keep that, look at it. It'll be in the Discord. I have the article that goes with it, but it was a simple Google search, you know. But I had never seen one like this one. So I think it'll be a pretty good tool for y'all to put in your toolbox.
Oh yeah, absolutely. And I like these visuals, like when you're sort of describing the evolutionary epochs, and we talked about the fusion of hydrogen into helium. You see those two in blue at the very top, right? And it says that during the Big Bang, right? These are hydrogen was forging into helium during the nucleosynthesis. That makes sense, right? And then you have the lithium, right? You see the lithium that we spoke of as well, right? So and so on and so forth. But yeah, I really like this visual. This is handy. All right. So let's talk a little bit about the evidence that supports the Big Bang, right? Because we always talk about, in terms of theoretical physics, right? How do we know, right? What in the observable universe tells us that the Big Bang theory is correct, right? And one of the things at the very top, we talk about the expanding of the universe, the idea that the universe is expanding, right? This is one of those things that fits very neatly into the Big Bang cosmological model, right? The idea when Hubble discovered that the universe was expanding, right, and his development of the Hubble constant, the formula that actually describes the expansion of the universe, the rate of expansion using the Hubble's constant, using distance and all these things, right? The expansion of the universe is something that's described within the Big Bang model, right? From an observational perspective, right, the cosmic microwave, right, that is one of the strongest pieces of evidence because the Big Bang theory actually predicts the existence of this field of radiation, right, that would happen as a result of the cosmic inflation and the streaming of those photons after we actually capture those in the bound electrons and some of those early epochs, right? So again, right, it was predicted, right, that this radiation would exist, right? And that's a good indicator. As well as the distribution of matter throughout the universe, right? The Big Bang model actually predicts that you would have a 75%, 25% helium and a hydrogen and helium ratio inside the universe, right? It also predicts that you would have sort of an uneven distribution of matter, so to speak, due to the inflation, right? Because based on some of the cosmological calculations that they do, they postulate that certain areas of the cosmos stopped inflating at different times, right? And the pieces that stopped inflating first, right, those are the more dense. Those are the more areas of more density, right? It also predicts that you would have voids in the universe as well. So if you actually take a look at that image, the sky map image of the CMB, right, you have like the yellow, the slightly yellow and slightly red. Those are the uneven distributions of matter throughout the universe. That's basically matter and heat, right? So those are three very strong pieces of observational evidence that gives credence to the correctness of the Big Bang theory, right? And again, this particular fact sheet here, we'll put this in our Discord as well. Any of the mods that's in here, go ahead and put a link to the Pseudo Killas Discord. This is for people who really like to have these type of conversations, right? We don't just talk about science, we talk about politics, we talk about, religion, we talk about pretty much everything, right? We listen to music. Go ahead and put that in for people that are interested to join the Discord. But again, the evidence for the Big Bang, right, is very strong, and this is one of the documents that outlines that.
And when you, let me say this, Brendan, about the Discord. We use sources over there. It's good to to come learn, but if you got a problem with using sources, that might not be the place for you because you think there's some gangsters on YouTube, but you get over there on that Discord without no sources, you finna get ripped. So.
Oh man, I'm telling you,
A pseudo
we get in weeks long
Can't see
back
you,
and forth. We get in weeks long back and forth discussions regarding topics, right? I remember us and Brother Sadiq and all of us, we were ensconced in a back and forth that lasted almost a month, right? It was really, really fun though. But yeah, shout out to the Discord community, right? It's really fun over there. But that pretty much concludes the evolution of the universe, man. We hope to do some subsequent presentations, basically, deep dive conversations on scientific topics. I would really like to do one on quantum mechanics, right? We have a lot of conversation and some pseudo, so to speak, conversations around quantum mechanics, like things like spooky action at a distance. Well, if you let us explain it, it might not be so spooky, Absolutely.
Yeah, that's a subject matter that people play in because they play in the subjects that's very complicated, and so they find a way of trying to make it common sense, and that's when they kill you. Remember that whole common sense thing? Yeah. I mean, the quantum world, your senses wasn't designed to figure out the quantum world. or high those high reacts. Yeah, come on, man.
Not at all.
I'm trying to see a piece right here. It's that fatal mistake about a whole bunch of. So you hear people saying, yeah, that's a whole bunch of hogwash right there. And I find that interesting that people wouldn't think that a group of people who just poison the whole planet Earth, like I'm gonna shoot the whole planet Earth up with a vaccine and and wipe out the planet Earth, and wouldn't think that was hogwash. I think people are actually doing that on purpose. I kind of realize that people just in here at their job, they model citizens. They don't say such a thing. They do their jobs and they get that check and they take their butt home and they good. But on YouTube, you can be anything you want to be. You can say anything you want to say. Yeah, you know what I'm saying? On your job, you be a raving nut saying half the things you say. Matter of fact, that's why they don't even allow you on your job to talk about religion and politics, because it can just get completely out of hand. Here you go, Mr. Scott. He said complete hogwash. Yeah, sounds like complete hogwash. Yes, it sounds like complete hogwash to the scientifically illiterate. Like, we get it, and it's not even a knock not to be scientifically illiterate, right? We're actually trying to raise the game. You know what I'm saying? We're trying to move the needle, right? We like at no point should the conscious community been allowed to promote illiteracy. Like, anytime you say, like, okay, Brendan and Kent and Anthony, I bet y'all know what the Dewey Decimal System is.
Absolutely.
How about you, Kent? You know what the Dewey Decimal System is?
Dewey Decimal System.
Come on, Kent. How old is you, Kent?
When's the last time you've been to a library, Kent?
I haven't been in the library in so long.
Block him out. Block him out. He didn't say that. Ladies and gentlemen, Kent did not say that. Anthony Bowman.
Kent's relatively young, right?
You is young.
Relatively young.
You is young. You might not know.
He was never subject to the pains of the Dewey Decimal System.
Yeah, you might not have been subject to that. If you don't know if you didn't hear that, you didn't know. How about you, Anthony?
I've heard it plenty of times, though. I'm just on a blank.
The Most High didn't enlighten me with that knowledge, though.
You never heard? Okay, hold on, stop. We got 4 people here, right? 2 have actually dealt with the Dewey Decimal System, so you can tell our age, right? 2 have not.
No, I've heard.
Ken heard of it. Yeah, but no, that's not good enough. You can't just heard of it. No, you can tell your age, Kent, right? Listen, the Dewey Decimal System was the way you had to navigate the library. And if you didn't learn it, you couldn't get to the library. You couldn't figure out where the damn book was. But what it did was it made you part of the process, right? It was fun getting a book. You would have to know it. You go to any library and you know the Dewey Decimal System, you can find your daggone book in the library, no matter how big the library was, right? And this is what we did. This generation here, right? Your libraries is online, all kind of stuff like that. They don't know. When you go in the library, you go to a computer, right? You type in the book, it tell you exactly where it's at, right? But that's kind of slowing down your learning process and making you think a little bit more, right? So people aren't spending as much time in libraries. Matter of fact, bookstores that people have to go into, like our favorite spot there, Kent. We love going into the it's closed down now, a lot of places. What's it called? The daggone Barnes and Nobles, right? Man, I love going to Barnes and Nobles, man. When my kids was young, I take them in there and run around in the kids section, grab books and read. Funnest evening ever, right? How many people do that? Now it's online. You just buy the book, right? You miss the experience or having a cup of coffee, right? These things were very, very fascinating and interesting. Going to museums, going to museum libraries, stuff like that. So, literacy and scientific literacy, man, is so you're literate, right? You have to have a certain level of literacy, right, to even begin to understand scientific literacy. So today's presentation, what age? Let me tell you something. I was talking to my editor today, right? And I'm not going to tell you the formal newspaper she actually works for. I'm not going to tell you that. Not going to disclose that bit of information, right? But what she said was, right, when she first got, to the paper, right, they forced them to write. They had to write a paper. They had to write an article for an eighth grader. She said it was the hardest thing she ever had to do. Because they would put it in the computer, they were like, nope, this is for a 12th grader. And they had to keep re-editing and re-editing it again. So a lot of times, like when I make this statement, people think I'm throwing shots. It's funny. It's funny that I know that you think I'm throwing a shot when I'm really not. See, that's the background me laughing, like, they really think I'm throwing a shot. It really feel like a shot, but I'm actually not. So newspapers have to write articles at a certain grade level. Right. And so, sometimes we forget because we use terms all the time. Right. And maybe y'all not familiar with that. OK, so question you, Brendan, what literacy level or what age level do you think your slides was for? Pull back one up. Let's see.
Okay. Let's see.
Let's see how this was. Let's take a deep look. Let's look at it real quick. This will be interesting right here. I thought you had it laid out very simplistically, right? If y'all go back and listen to the show, yeah, all right.
Okay.
No, good.
There.
Yeah, right here. So, okay, so you got the era of atoms, okay, Planck era, okay, saying that right here. You remember at the beginning of the show, I mentioned nuclear synthesis, right? Okay, we talked about understanding, like the creation of the elements, right? That's essential. So we're actually having conversations with people that don't even understand that. I never forget, young Ferrell said that carbon one day, right, was going to be 655. He doesn't even know that if you change the atomic number, remember you was in the 6th and 7th grade, you learned about the atomic number. Put up the element chart real quick. Watch this. Now this element chart was the best element chart I've ever seen in my life. Shout out to Anthony. Now this is deep. Watch this. That's the best element chart I've ever seen. First of all, it's color coded. So this is definitely 6th, 7th, 8th grader type of thing right here. Trust me. It's color coded, right? So if you see the blue, that's the Big Bang, right? The Big Bang fusion, right? Remember Sanchez and them keep talking about the sun is fire. They don't know what they're talking about. Remember we explained the difference between when human beings create thermonuclear weapons, they split atoms. Those nuclear plants like Chernobyl in Russia, right? They split in atoms. And the byproduct from splitting the atom is radioactive material that stays radioactive for millions of years. They don't even know where to get rid of it. It's the most dumbest thing to do, actually, right? Humans, right, we trying to get past that, right? But what nature does, look, Big Bang fusion. And then what's the element to go with it? Look, 1 hydrogen and 2 helium. Y'all see that? So where's the rest of the blue at on the map? Look for it. So what is that telling you? That's telling you, right, that hydrogen and helium. Now watch this. You see right there, right under hydrogen. Hold on, let me do this. Watch this. Right? I just want to show everybody that the slides was really made, right, for a middle schooler. Watch this. Look. You see 1 hydrogen and 2 helium, right? And then you see Li, that's lithium. Now look at the color blue. You see, not the whole thing is lit up, but 1/4 of it is lit up, right? My fault, like 1/3 of it is lit up. So they saying that, look, during the Big Bang fusion, you had hydrogen and helium and a little bit of lithium. You see that?
Right. Yep.
Now, if you can't read a daggone, now you, nobody had to tell me this. I'm sitting here looking at it. Listen, watch this. Let's go to the cosmic ray fusion.
Right, and that's the era of nucleosynthesis, right? We talked about the whole idea when the universe was a hot plasma, right? And that plasma was so hot, right, that it was knocking the electrons out of orbit and all those things. So this is still very early in the evolution there, right? So during the cosmic ray fusion. Those are the gamma rays. The gamma rays was causing that. Yep.
Look on the chemical element chart, ladies and gentlemen. I heard people say life ain't chemical, but wait a minute, the elements are. Right? Because you never looked at the map. Look, you see it. 3, you see 4, you see the atomic number. Look. All right. if you come down to exploding massive stars, right, or dying, low mass stars, exploding massive stars, right, exploding white dwarfs. You see all the corresponding numbers, yo, when these things was created, yo. This is the greatest daggone look. Radio, what's this? Very radioactive isotopes. Nothing left from stars. Look at that. Look at that, man. This is the best thing I've ever seen in my life, yo. And it ain't take me. It just I'm looking at on purpose. On purpose, I waited to now to really look at the thing. I wanted to see. Could I just look at this and understand what it was doing? Now, just because I can do it, don't mean that nobody else can do it. But I'm trying to let you know that I don't have a master's degree. Brendan does. Brendan has formal training. I don't have formal training. I got formal training in the damn street, which is bananas, right? I did pretty good in high school and middle school. All right? I paid attention because you get joked. Where I was from, if you was done, we used to laugh at the people that was failing. We didn't understand that. You get laughed at. Well, you failing, boy, that was the biggest joke ever. That boy fell right there. You get cracked jokes on. I know I was the main joker. I know you was, Ken. You
Man.
So yeah, we want to. I say all this to say, man, like, the joke be the literacy level, right? And we don't use a lot of these things in school. So I mean, when we outside of school, you've been away from school 20, 30 years, and so I'm letting you know, if you're not always reading, books like this and all that, your literacy level gonna fall down. And then if nobody actually showed you how to read a scientific journal, you're gonna be in trouble, right? And then if you arrogant with it, like the conscious community is full of arrogant people that think they know, right? Remember, it's full of people who are science deniers. The whole conscious community is science deniers, right? You can read the comments, all right? They deny science. They deny the power of science, right? And they glorify the power of religion. Watch this. The whole time while they saying that they now out of religion, right? They claim, watch this. They actually glorify religion the whole time saying they finished with religion. They won't do religion no more. We're not Muslims, we're not Christians. Then they go into this whole pseudo smear, and it's interesting. So Brendan, I don't know if y'all want to stop right here, man, and do another show and open up the panel. Let everybody come on, because I know you kind of wanted to, not mix that in, because it has to be a time with people that are subscribed to the Pseudo Killas and the Solid Universities, man. It has to be a presentation where they can stop it and start it and get some good quality information without a whole bunch of mixing it up and faking this out and feeding into that. We just have to do that. You know what I'm saying? Everything
absolutely.
can't be high level God killer act wild. Nah, come on, y'all. We gotta make this sit still sometime.
And this is one of them ones you got to keep watching back over and over again to really grab that jump, really understand it. So I've been learning things since you started, yo. I know I'm gonna go back and watch it.
Yeah, because we got a lot we talk about all the time. That's why y'all got to get in the server, man, and start to immerse yourself into certain terminologies, right? Like none of y'all gonna watch this. Do y'all know how hard it is for you to get me when I say that human beings, right, have been around for 350,000 years? Homo sapiens sapien. Then I say, but human beings go back to at least what? Maybe 2.5 million, 3 million, somewhere in that, humans, right? You say, well, I say now Homo sapiens sapien, and you confused right there, see? So there's a certain amount of information you gotta have that will make it make sense to you, right? You can't play with definitions. The conscious community is the play with definition community.
That's how they messed up that Lucy. When did the community thing and that Lucy was a black woman. And then you look at her in the textbook, she look like a whole monkey. But she
it did like a monkey. It did. And then the whole look like a monkey thing is wild. Because you can look like a monkey and not be a monkey, because we done definitely seen something. Let me stop.
That's how they keep messing up theories and scientific theories and stuff like that too. It's a simple Google search. Scientific theories, scientific laws, facts. It's a simple Google search. We're enthusiasts, man. You know what
I
I'm saying?
swear I
At
want to
least out
drop
of
that link for
6
Chino, for Chingo. Oh, I want to drop the link for Chingo.
Yeah.
Chingo.
Yeah, let's
You
stop
wanna
this show and start another one, and then we can maybe open up the panel and have some discussions. Yeah, absolutely. Again, it's a lot of information to sort of absorb, and I think you said something very interesting in terms of being able to grasp a lot of this stuff, right? So that the whole idea, even me myself, I have a difficult time truly understanding the nuclear weak force, right? So that's something I'm still delving into because it's one of the most mysterious forces in terms of how it works, right? The whole idea that the universe is 900 billion light years across, right? Wrap your head around that, right? The idea that it's 100 to 200 billion galaxies, not stars, galaxies in the known universe, right? And each one of those galaxies have trillions of stars, trillions. It's a lot of it. It's hard to wrap your head around, but think about it, right? Us existing and contemplating these things, right? It's the universe sort of staring back at itself, right? Because it's one of those things. They say that we are made of star stuff, right? Everything on that chart that you talked about, right? The atoms, the elements, everything in your body was at one time forged within the era of the Big Bang.
We are the universe that became self-aware.
Right, absolutely.
We are the universe that became self-aware. They like that. They stardust is sprinkling their head on that statement. Love that.
Right, but don't jump out the window with it.
Don't jump
They
out the
jump.
window.
No, they jumping. I told you, man. They was tricking us the whole show. I knew it.
They gonna clip me and have me say
Oh yeah.
what he really did.
All
right, so this would be the Big Bang after show.
Dark matter, that's an interesting conversation, right?
Yeah.
It sort of ties into the conversation we're having now. So if you want to jump on and talk about dark matter, we can do that.
Yeah, what about dark matter?
Not dark matter, black matter. He want to know about black matter.
Oh yeah.
But it's all.
Yeah, it's funny.
Again, those are the sort of sensational topics that related to cosmology and astrophysics, right? These are the places where we don't have all the answers, right? And again, we can have that conversation, right? If you want to jump on, absolutely.
Yeah, we do it, and we play some clips. Do it for an hour, have some fun. Let me see. We put that in there real quick. All right. Time is it?
Do you want to end this show and start another one?
That's exactly what I'm gonna do. I'm doing it right now in the middle of doing it. You feel me?
Okay. Yep.
Yeah, of course. Brendan funny. Just say it, Brendan. Just say it, Brendan.
I don't want a rabbit flat earther jumping on and saying, what do you mean? You got to take the gravity out of that quadrant right there. You substitute that with the buoyancy and density, and then you take your electroforce, that's magnetism, and that's replaced with gravity.
Man.
What was that word? Distortion, electromagnetic distortion. What are you talking?
And where's the Kundalini? What's the Kundalini in that? No.
You say what's the Kundalini in that? The Kundalini.
I'm trying to teach y'all holographic distortion.
Oh man.
Man.
Yeah. All right. Hold on. I'm gonna drop that link. That's funny, yo.
I'll be right back, fellas.
Yeah, I'm gonna go get the link. Hold on, I'm gonna get out of here. Go get the link. Get the link for everybody. I'm gonna put it in the thing. All right, set that up for you so we can get right to it. Doing this on Sound of the University, man. All right, hold on. It should be fun. Should be that interesting. Because it's definitely a pseudo crisis. I see you on that, yeah. questions in here, man. Man, I appreciate everybody that slid through, man. I'm gonna get this. Let me get back over to here. All right. Back. She saying the RBA. I ain't do the RBA, man. Yeah, we're gonna strike that RBA up too. Oh, let me see. Hold on.
We gotta do that.
Yeah, I can strike. Let me see. Hold on. I think we can. Hold on. Hold on now. All right, here. I put that link in there. Here, I'm gonna give y'all the link. All right, let's give me the link. All right, I'm gonna go back over here. Go edit it. Edit it, and I can. All right, y'all can tune in on. Hold on. All right. Make sure y'all all got that link over there, man. Y'all got the link right there, right? Put this in the chat again. Hey, man, look. Make sure y'all go over there, man. Now y'all can come with y'all questions. Y'all can talk about the theory. Talk about Sanchez, man. You know, we're gonna stream this from the RBA channel and the Sarnetta University. It's gonna be a Sarnetta University after show special, man. I appreciate everybody coming through, man. Appreciate the quality. Very, very simplified, clear to see slides, man. Go ahead and rewind that. Like some material like this, you know, I'll listen into my car, right? I'll be home on my TV. I'll take some notes. I'll take the slides, right? I'll look at the element chart. I think the element chart, big up to Anthony, man. The element chart was the best chart I've ever seen in my whole life, bro. Like, that's it right there. I can take that and beat all y'all up with that. Don't give me that tool. It's over with. Hold on. What did you say, sir? What did you say? What? You know that's right there? Quality material. Brendan, you did it once again, bro. That's one of them. You know how they say it? That's right there, bro. Very, very, very there.
Expert over there, yo.
Yeah, very, huh?
I said he sounded like an expert over there, man.
Yeah,
No.
yeah.
I point you to the experts, brother.
I'm just saying.
Point you to the experts.
No, don't do him like that.
Right.
Don't shoot him like that. He sound like a science advocate.
And surprising enough, we got through all of that content, right? 8 evolutionary epochs of the Big Bang without getting ensconced in one formula,
right?
Without one mathematical formula. Again, right? Being able to explain these things at a high level, right, and in a way that's digestible for our community. I think that's a very important thing, right? That's what I didn't want to do. I didn't want to jump in and start delving into a bunch of equations, talking about Newton's theory of gravity and all of these things. We could have did E equals mc squared and special relativity, right? Again, all of those things are at play, right? But for these particular introductory sort of framing conversations, these high level framework conversations, that's not needed, right? And this makes these particular topics approachable to our community as well. You don't necessarily have to be a math genius to absorb this type of information, right?
Right.
Y'all know what it is, man. It's the center for the study of pseudoisms, man. Pseudo Killas on deck, man. With that, man, we going right over to the other channel, man. Yo, Sarnetta University, man, is in effect, man. Appreciate everybody that came through, man. Now we can get it in real greasy style. Y'all already know what it is, man. We did the nice, smooth, clear crystal, yo. Now it's time to go ahead and do what we like to do, man. With that, man, yo, appreciate y'all, man. Pseudo Killas on deck, man. We'll be back over the channel in a couple weeks, man. Y'all know what it is, man. Appreciate y'all, man. Brother Anthony Bowman, man. Brother Kent, man. Van Sirius B. That's my favorite name right there, man. And all the Pseudo Killas, man. Y'all go check these presentations out, yo. With that, man, we out.